All right, so my project for Module 1 is about understanding measures of central tendency and their importance. I chose this because not only do I think it's like one of the more important aspects of statistics, I think it's really important to know what you're looking at in measure in like understanding mean and median and the differences when looking at statistics, just to be an educated consumer. But also, I feel like this is something that everyone needs in their life, and me especially going into a field of psychological science. I'm probably going to need this for the rest of my life, and I think it's super important. All right, so the first slide that I prepared is about central tendency and basically what it is. I describe here that there are three main measures of central tendency: mean, median, and mode. Mean, which we talk a lot about in class, is basically the average of all the values in a data set, or you can take the mean of a particular variable and find what the mean is of that, which would be helpful if you're like comparing and contrasting variables and things of that nature. There I included the formula for mean, but the easiest way that I found to do it and doesn't include the formula, or I guess it does in a sense, but it's just easier for me to understand at least, is just to add up all the values and then divide by the number of values that you added up. This may seem a little elementary, but it's the way I understand it and I get by doing it. So the median is the center value in a data set when it is ordered from least to greatest. You get a median of a data set when 50% of the values are larger than the median and 50% will be smaller. So that's how you know you have like the middle value if there's 50-50 on either side. And then the formula to find the median is x times 2n plus 1. And then the mode isn't really important in the context of this presentation, but the mode is another measure of central tendency, and it is the value that occurs most frequently in the data set. So say you had a data set of, I don't know, like test scores, and you measured 10 people and 7 of those 10 people scored a 5 on the test or something like that. 5 would be your mode because it's the value that occurs most frequently. And then another important measure of central tendency, I mean, it's not really a measure, but it's a bell curve, and that is what is known as a normal distribution or a Gaussian distribution. This is kind of like the gold standard in psychological science, about how data should look and what basically is the most appealing to articles, viewers, and publishers. That I don't know what just happened. Hold on. Okay, so it's basically just the most valuable, not valuable, but it's like the most standard form to distribute data and to show data. A normal distribution guarantees that 95% of the data is 2 standard deviations from the mean. So that's another reason why it's so popular to use, because it's easy to read, it's easy to understand. You always know that 95% of the data is 2 standard deviations from the mean, which makes sense. And it doesn't leave much room for discrepancy. But later in the presentation, I'll talk more about why maybe this isn't the best thing in the world. All right, so given the data that we were given for this particular project, I tried to make a story out of it. It completely, it's just a story. It doesn't really make a whole lot of sense, but looking at the data, I still could understand it. So what I did was I measured gratitude level, or I applied the data to measuring gratitude levels between men and women. The blue graph is for men, the green graph is for women. So the green graph, as you can see, is a bell curve. It looks normally distributed. There is a little bit of, I don't know, it's not 100% normally distributed, but it's good enough and it makes sense. It looks like a bell. Um, so, but in the men's graph, there's obviously slightly a negative skew. It's not normally distributed, and there's overwhelming spikes in the early negatives or the early positives. So and then the graph here just talks about the mean, median, standard deviation, and the variance, which are all seen in the histograms as well, but it's sometimes helpful to see the actual numbers of it. So what I wanted to talk about is trimmed means. So this goes back to make in psychological science that everyone tries to make the data look normally distributed. So normally distributed data is the gold standard in psychological science, and there's a chance that the data that looked like the MEN score in this example study would be transformed using trimmed means to make it look more significant in this case. If you trimmed it more, I'm sure you could get it to look normal, but in this case, I just trimmed the data by 20% to make it look more significant. Not that the data wasn't significant, but like if I'm a consumer and I'm looking at an article just casually, I feel like this would draw my eye more than the graph on the previous slide because well, I don't understand what these outliers are or these outliers are. But if I looked at this graph, I'm like, wow, a they're really they spike at really either positive or really negative views of gratitude. So that would just be something to get more clicks and more views on an article, and it would probably get published more. So trimmed means is a way to make transform the data to look something more interesting. So if the mean of the men's data is trimmed by 20%, this changes the mean to 0.09037. And the new distribution looks like the histogram here. So in my opinion, this data with the trimmed mean is much more interesting to look at, and I'm sure it would be easier to publish as the data looks like it would get, or data like this gets more clicks than data previous. And that's just because, people, when they look at things, they just look at pictures and they're like, oh, that's interesting, or oh, that's interesting. And they don't really think critically about the data, which is fine. Sometimes I'm guilty of that too. Um, so then that leads to a more ethical question. Is it worth it to compromise the data integrity to achieve a more interesting distribution? Because of course the data I just showed and then the data of the first graph before I trimmed the mean looked a little bit different. And I think the question here is it ethical? Because you are excluding some data when you trim the mean, and that data could be important. I think it's important to look at it if you were looking at the scale and there's a couple outliers. I think outliers are important in certain situations. Maybe not exactly in this study, but I think in general, when looking at psychological science, it's important to consider the outliers because then again, not everyone's the same. There's always going to be outliers. So why throw away their data entirely? Doesn't make sense to me. So the idea of a trim mean is interesting because although they make the data more interesting to look at, they also exclude part of the story. In the case of our example, variables in this example study, if the histogram of the trim mean was presented, the reader of the study wouldn't know that the data was negatively skewed to being slightly more grateful. And they also would perceive a larger middle ground when in reality it is much smaller. Because if you just look at that graph, although the numbers and the x-axis of the scale has the same values, basically, it appears much larger of a middle ground, even though technically it's not, but it appears that way. And if you're just looking at the data, like a quick glance, you would see, oh, why is there such a large middle ground when in reality it's really not. So the ethical issue comes into play even more when the distribution becomes a normal one after trimming the mean. Although the distribution in this study didn't become normal after trimming the mean, psychological science puts an extreme amount of value on a normal looking distribution. A lot of the time, data is altered to look normal. And again, this comes back to the issue of data getting more clicks and being published more, therefore spreading findings on the study. However, the appearance of the data doesn't tell the most valid story. And I think that's just something in science that has always been not an issue necessarily, but it's always something that has happened. And I think if psychological science wants to become more of the quote unquote hard science or wants to become more valid, because people hate on it a lot. And sometimes they're valid for hating on it because, it doesn't always make the most sense and everyone's different. But I feel like if the data wasn't always transformed to be a normal distribution or transformed to look a certain way, it would have a little bit more validity in that sense. And yeah, that's my presentation.